Now, keep in mind as we're working through these in the book, sometimes you're going to have where you've got what you've been working, where you do have a solution to the problem, okay? So it's just in that final step that you're making that decision. Okay, so I'm going to go ahead and do my distributive property. 4 minus 6 with my x is equal to 4 minus 4 times 1.5 is 6x, okay? Here's my equal sign. I like to work to get the x to the left side, so plus 6x cancels it out, plus 6x. Oh, once again, it canceled out. Negative 6 plus 6 canceled it out. It gave me 0 x's. Now, here's what I'm left with. I have a 4 equals a 4. So here I ended up, is that a true statement? Yes, it is, but I didn't find out what x equals. So this would be a situation where when we ended up with the same number on both sides, this would be an infinite number of solutions, okay? I could put an infinite set of numbers in place of 4 in this equation, and it would still be an accurate statement. I could put 8 in place of that. And as I work through the problem, I'm still going to get 8 equals 8. Okay, the x in there is not going to change anything. So here, because we didn't find out what x was, but we have the same number on both sides, that would be considered an infinite solution. Okay, so let's try another one of those. And then I'm going to have you practice a couple. Okay, so working a little more distributive property again. So now I'm going to do white. Okay, so 3 times 4, 12 with our x. 3 times 1, so minus 3, equal sign. And then I already have 12x minus 3. Oops, forgot my x there. Okay, so now I'm going to work to get x's to one side. I like to work them on the left, but you can choose either as long as you're doing the opposite. So minus 12x minus 12x. Remember, we're doing the opposite when we shift to the other side of the equal sign. Okay, so here, 12x minus 12x canceled it out. I got 0 x's here. There's nothing there, so it's really canceled out. So I have negative 3 is equal to negative 3. So once again, I got the same number on both sides. The x had canceled itself out. This would be an infinite solution. We could put an infinite number of numbers in place of where the 3's are in my equation here that I simplified, and it would still be a true statement. So same number, where when our x's have canceled out, is an infinite solution. Okay, so I'm going to have you guys try a couple to give you a chance to kind of check yourself out. Now here's the thing. I want you to remember that as you work through these, sometimes it's not always going to be a no solution or an infinite solution. Sometimes you're still going to get a solution, just like you have in the first 3 lessons of the book. That's not going to change. It's just when you get down to that final step, if you have no x's left over, that's when you're looking at a no solution or an infinite solution. So work your way through these problems. Pause the video, go ahead and work your way through these problems, and then check back with me and see what your final results should have been for these 2 questions. Okay, so you'll notice in number 1, you should have ended up with an infinite number of solutions, because when you worked your way through and got rid of your x's, you ended up with 42 is equal to 42. And on number 2, in this case, I know that it looks like, oh my gosh, if I look at that initial problem, they look like everything's going to cancel out. But here's the thing, when you look at your x's initially, 1 was positive, 1 was negative. They're not going to cancel each other out when they shift to the other side. So don't get too quick. Just because this lesson is introducing no solution versus infinite solution, you still are going to have some problems in there where you're going to get a solution. So don't look really quick and say, oh, they're both 3's, they're going to cancel out. Pay very close attention. Sometimes you will get a solution. Okay, so you're gonna go ahead and work through your workbook pages. And once again, those were pages, I think 14A and B. I'll double check that really quick. Yep, 14A and B, you're gonna work through those. And then when you're finished, check back with me and we'll go through and kind of see where you're at. If you need help with number 11 on that practice problem, go ahead and check with me, but it is asking for perimeters, and remember perimeters is adding together the outsides. Okay, so you'll just set them up as the triangle is equal to the perimeter of the rectangle, and you will work through that problem to decide if it's a no solution, an infinite solution, or if there is a solution.